Okay, so in this video, I want to talk about projections. Okay, so what is a projection? Let's call that vector u, let's call that vector v, okay? And we write it like this. Project the vector u on v. Vector u on v. So what is this? Well, here's our u projected onto v. What it means is that get the component of u's vector on v's direction. Okay, so that means we need to draw a perpendicular line here like this. What we want is this vector right here. See that vector right there? Maybe I choose a different color. This vector right here is the projection of vector u in the direction of v. So I'm not talking about the size, I'm actually talking about that vector. So there's two things we need to find. Any vector, you need to find the size and you need to find the direction. Okay? So that's a bit tricky. The size, okay, the size, if we have this angle here, is relatively easy to find. That's called a component. Okay, the component. So if you write projection uv and you put a magnitude, that means essentially the component of u's vector on v. Okay, so that means get the magnitude of u and just times it by cosine of theta. That gives you the size only. Okay, but we further need the direction of v. Okay, but we need it in size 1, the unit. Okay, we need to, so we call that normalizing v. We need to normalize v, meaning get v's vector v but make it into size 1. And this is how we do it. V, we just have to simply divide by the magnitude of itself, then it turns, okay, it turns the vector into unit 1. Okay. Finally, we can say this right here is the u absolute value cosine of theta, right, times by vector v over the magnitude of v. So this is just the pure size, and this is the unit vector. So this is, we say the magnitude, just the size, and this right here is the direction. Okay. May look complicated, but it's actually not that bad. Okay, it's not that bad. So a few examples, and then I'm going to give you actually even a simpler formula. So let's say we had a vector like this, and this was u, and the magnitude of this is 5, and let's say this is v, and the magnitude of this is 2. The angle between them are 50 degrees. Okay, so we want the projection of u on v. Yes, okay, and we got to do it in 2 separate parts. So first get the magnitude, okay, and so let's call our this vector here w, the projection u on v. Note that projection is a vector, it's not a scalar. Okay, because of this part right here. All of this, okay, the rest of it is purely scalar. But we're multiplying a scalar to a vector, so the end result is a vector. Okay, so then the magnitude of w is going to be u cosine of 50 degrees. That's 5 times by cosine of 50. Okay, so the final answer will be just projection u on v. The magnitude is equal to 5 times cosine of 50 degrees. I'm not going to punch this in the calculator. You can do that. At the direction of vector v. Okay, that's all you have to say, because they didn't give us vector v as an algebraic vector. So we can just say, well, it's on that direction, okay, with that magnitude. So let's actually do one with algebraic vector. Okay, so we can actually be more specific. So let's say you have a vector u is, let's say, 2, -3, and v is equal to -1, 3. Okay. All right. So then we first need to find the angle, right? We need that angle between the two. So cosine of theta is u dot v over the magnitude of u, the magnitude of v. So that's going to give you, so let's do that. -2, -9, u is 4 plus 9 square root. The magnitude of this is 1 plus 9, so -11 over root 13 and root 10. And theta will be cosine inverse of root 130. So we get that, okay? So that means the projection of u on v, the magnitude will be, get the magnitude of this, which was root 13. Root 13 cosine, okay, cosine of this. But note that cosine of theta was already given, right? We didn't actually have to go this far. Cosine of theta, just this value right here. Okay, so it's going to be the magnitude of -11 over root 13, root 10. And this cancels out. Well, that's kind of, is that a coincidence? That canceled out? Well, we'll find that in a little bit. Okay, so that's the magnitude. And now we just have to get the unit vector of v. So that's -1, 3, right? Divide by the magnitude, which is root 10, which is -1 over root 10 and 3 over root 10. Okay. So finally, projection u on v, okay, is going to be this multiplied by that. That's the magnitude, that's the unit vector. Okay, so let's multiply it in. You get -11 over 10 and 33 over 10. Okay. Now, that was a pretty long process. We can shorten it. Okay, we can shorten this. And I'm going to show you how we can shorten it in the next video.